Hey, what's up, everybody, and welcome to a new episode of machine learning. In the machine learning journey, I'll skip this one. In the supervised learning section, we went through the algorithms of linear regression. That is, the types of linear regression are multiple linear, mean multiple variables, and polynomial fit, that is, a nonlinear equation. Then we also saw the decision tree, that is only classifying the data. Today, we are going to see a random forest. Well, in the random forest section, I never use this code in any of my research, but I know I have a small concept of how it works. But if you, in the comments, if you ask some difficult question, then I may not be able to answer it. Maybe I will show the code. I'm using the same sklearn Python library, and to get some decent results. But in the future, I will make a detailed video out of it. But for now, it's just to show how you can grab a sample data and perform a random forest algorithm on the top of it, and then what random forest means. That is the purpose of this video. And the sample code will help you to it's a ready-made code, and it will help you in understanding or applying it in detail. The idea is that that this world is more of like fast work. So then if you have this small random codes, small codes ready, then with small tweaks, you can apply these codes, get a quick insight out of it, communicate to the management team, or participate in some competitions. There is no time only to read into details, and this maybe when you have free time, go into the details, like as I do. Okay, we saw the random forest. We saw a decision tree in the last video. Please check out the playlist, and you can see the decision tree. We had a good session about that. And the random forest is just a step up or a level up from the decision tree. Well, it's an advanced form of decision tree. I tried to be as simple as possible so that people can understand. It can be used both for prediction as well as classification. What random forest does? Random forest means it's a forest. It has a lot of trees. So in this algorithm, it will create many decision trees. Whereas in the decision tree algorithm, it creates only one decision tree. It classifies the data. Whereas in random forest, it will create multiple decision trees and take the average out of all the results, and then give us the final output. So this is a level up than decision tree, and it gives more insights, or more near to the truth kind of output. So the steps are, pick a set of n random records from the data set, then build a single decision tree, and continue, then again pick random records from the whole data set again, and then create a decision tree. Then again do it. It will do the number of times that you mention. Suppose 20 times do it, 30 times do it, or it depends on how many times you want to do it. And it also depends what results you are getting as an output. If the results are increasing with more number of decision trees, then go for it. Then finally, for the new data, the predicted output is the average of all decision tree outputs. That is for the prediction part. Means it can do prediction as well as classification. For prediction, it takes the average of all the decision tree outcomes. And for classification, to classify a new record, it is based upon majority of vote. For example, if you create 10 decision trees and 9 out of 10 decision trees says that this random data set is more inclined towards, suppose you have a data set of person name, age, and salary, and a label rich or poor. Then if 9 decision tree says the random data sets are more inclined towards rich, then you will get a model which is more inclined towards the output of rich than rich as a label, just like tag, rather than poor as a tag. So that is the whole sole concept of random forest. And if you want to read into the details, then you can check many other YouTube videos or research papers. There are many papers on this, and you can. It's fun to test these algorithms and see what outcomes I get. Okay, two. I have prepared two codes, uh, one for classification and one for prediction. I am going to test each one, but first let me explain. I have a data set of petrol consumption by people. Let me show you how the data set looks like. It's for classification. Okay. Okay, so the data set says petrol tax, average income, and some other columns are there. I didn't elaborate, means I didn't show all the column names, but this is also a random set I created. I used rand value in the CSV file, and the label is for whether it gives 0 and 1 as a label as an outcome, and based on we will apply the forest, so the random forest algorithm on it, and see what is the classification it does. The algorithm is super easy, and the column from 0 to 4 belongs here in the data set, and the label is in the y variable, recorded variable. Then dividing the data set into 70 30%, 30% the test data set, 70% is for the model fit. Then I am using the library called sklearn, and it uses yeah, these two components from the sklearn to split and to apply the model fit. Then random forest regressor I am using. So in the decision tree, it used decision tree component or the class, and here it uses random forest regression. So sklearn has everything in it, and you can use it, this ready-made library, to perform on the sample data set to get a quick outcome and see what it gives. Then I am means after the model fit, I am performing and predicting here, and then seeing the what results I'm getting. If I run this code, and then for model creation, I'm using sklearn ensemble library because it is used to solve regression problems via random forest. This is the only important thing that you have to know. And here I have given 20 number of to create 20 decision trees, and then from the 20 decision trees it will take an average to further perform the predictions and the classification. It's a trial and error to get the best result. For classification, I didn't perform the classification here. I just performed the prediction here because I was getting some errors, and then I didn't want to get into the details of debugging it. I will debug because I am in the process of traveling and I have less time. So that's why I just perform the prediction. And here I don't have to show, maybe I will wrap up this whole uh, video in going directly here. I didn't perform the classification. I'm just using the prediction. Maybe you guys can see this code will be available in the GitHub, and you can directly look into it and debug it to further perform the classification. It will not show you the 20 decision trees. Well, you can see it, but that is not required to see it because it always does an average for the prediction. Prediction we already saw. It will just fit, then use the sklearn ensemble, and in order to see the mean square error, root mean square error, and mean absolute error, I'm just doing some additional steps here and perform and running the metrics to see how good is the fit. But I don't have to perform this one or do this one because till here we already saw the code in this Python script. Here I'm just applying some metrics. Okay, let's run it. I'm applying the prediction on the same petrol consumption data set, and you'll see that it's not good enough, because I created a random data set, so it's not good enough. But this is what it is. If I have if I have a real time data or a real data, then I think the results, to check the result to see how the prediction is, will be more insightful. For now, this is the, I mean, this code will be available in the GitHub. So use it, test it, play with it, and see what you are getting. Maybe you can perform, change some parameters, and see whether there is an improvement in the results or not. So you can play around with that. This is what I wanted to share, and this is how the algorithm is used on a sample data set to get the results. And yeah, you can add more visualization to it to see how the random forest is getting developed, and see you can do a hell lot of things here. Okay, have a nice day, guys, and we'll see each other in the next video. And in the next video, we are going to see the logistic regression part. Logistics regression is the, so this is what I wanted to share in the supervised learning part. So we discussed about the linear regression, and from the linear regression we saw multiple linear and polynomial. We also saw the code for decision tree. We also played with played with the algorithm of random forest. Now we are tapping into the classification part, and okay, unsupervised, we'll see, not now. So this part is done. I'm not going to show you any algorithm of neural network, because I, in the past, I did something with the convolutional neural network, but it will take me a lot of time to explain you guys. And neural network I hardly use in my day-to-day work, so I will skip it for now. But that is also a part of the regression. We will directly go into the classification, and I will start with the logistic regression in the next episode. Okay, have a nice day, guys, and we'll see each other next video. There is a spelling mistake here. Sorry, guys. Okay, see you guys.